Section 1.4, circles. A circle has a center and a radius. We can define a circle as the set of all points that are equidistant from some point called the center. A circle is a graph of an equation. Well, let's derive the equation for a circle. I'm going to first draw a picture of a circle. Its center will be at HK, and the distance between the center and the outside we'll call a radius R. And the point where the radius hits the circle will be XY. Now XY can stand for any point on the circle. And notice that this point that I have labeled here, XY, is one of those points. But we can imagine it being any point on the circle. So a point here, anywhere. By the distance formula, in section 1.1, we know that if we take the square root of the difference between the x coordinates of 2 points plus the difference squared, plus the difference of the y coordinates of 2 points. So notice here I'm taking x and h, y and k. That is equal to the distance between those 2 points. Well, the distance between those 2 points for us is r. Now if I square both sides of this, I get x minus h squared plus y minus k squared. Fix that. Equals r squared. And that is what we call the standard equation for a circle. This is the standard equation, standard equation for a circle with center HK and radius of length R. Notice that the equation has 2 minuses in both of the terms that are added together. Okay? So if we're asked a question like what is the center and radius of a circle, x minus 3 squared plus y plus 7 squared equals 25. We can see that this 3 is sitting in the same position as the h in the formula, and the 7 is sitting in the same position as the k, although in our formula we have a minus, and in our equation here we have a plus 7. What we can do is we can rewrite that plus 7 that's with the y as minus a negative 7. And we can also write the radius, or this 25, as 5 squared. So now we can say that the 3 is h, -7 is k, and 5 is r. So the answer to our question of what is the center in the radius, we can say that the center is the point 3, -7, and the radius is 5. So notice the x and y coordinates of the center actually end up having opposite signs of the numbers that we have inside the parentheses being squared with x and y. Now that we know that the center and the radius of this circle, we can actually graph it. So I'm going to put a point at 3, -7, because that's where our center is. 3, -7. And to draw the circle, I know that the radius is 5 units away from the center. That's going to be true in any direction. The easiest place to draw that is straight up. Pardon me, that does not look good. Is straight above the center. So if we go up 5 units, that's going to be at 3, -2. If we go down 5 units, 1, 2, 3, 4, 5, we find a point at 3, -12. If we go over to the right 5, we're going to find a point at -2, -7. And if we go to the right 5, we're going to find a point at, that's 4. 3, 1, 2, 3, 4, 5. 3, 4, 5, 6, 7, 8, -7. Let me erase this label so we have some space to draw a point. 8, -7. And then we do our best to, oops. Then we do our best to draw a circle. My circles aren't very well drawn, so I don't expect yours to be either. But as long as you have the points marked and labeled correctly, then that definitely is the circle. Okay, there's another form of circles that we often see, which is the general form of a circle. And it looks like this: x squared plus y squared plus ax plus by plus c equals 0, where a, b, and c are real numbers. Notice that in this form, there's no r, there's no h and k like there were in the other form. So we can't usually use this form to find the center or the radius, which would help us graph. So we need to transform something like this into the standard form of a circle in order to graph it or to find the center and the radius. Okay? How do we do that? Well, we can complete the square. So I'm going to ask a question, which is, what is the center and radius of the circle 2x squared plus 2y squared plus 8x plus 6y plus 7 equals 0. Notice this is in the general form of a circle. Well, almost. Now, my goal is to put it into the standard form. This is what we do. The first thing that we do is move the constant term to the non-zero side of the equation. Now, there's a common 2, factor of 2. I'm going to factor that out because I need to make sure that x squared and y squared only have 1s as coefficients. And to kind of get rid of that factor, I can divide both sides. So I end up with x squared plus y squared plus 4x plus 3y equals -7 halves. All right. All of that is preparatory work in order to start completing the square. Completing the square means to make perfect square trinomials, to complete a polynomial in order to make perfect square trinomials. You may have seen this used for solving quadratic equations in the past, but it's a tiny bit different. So what's going to happen is I'm going to make a perfect square trinomial in x here, and a perfect square trinomial in y here. Notice though that I'm going to end up adding some terms to the left-hand side, so I need to add those same terms to the right-hand side. If you recall the equation for a perfect square trinomial, it's a squared plus 2ab plus b squared. If we look at the x, the polynomial here, the trinomial that we're trying to create in x, I can see that x is the same as a. If I think of 4x as 2ab, if 2 is in the formula, and a I know is x, so this would be like 2x. The thing that I need to make it 4 would be another 2. So that tells me that my b is 2. So b squared will be 2 squared, or 4. So 4 is the number that I'm going to add on the left to make a perfect square trinomial, and on the right. Now if I'm looking at the making a perfect square trinomial in y, I'm thinking about the same formula of a squared plus 2ab plus b squared, but it turns out that 3 can't that easily be written as 2ab. Or you might think that. Take a look at this. If I do 2, I know that a is y, right? I know that I have 2 times, ab, so 2 times y here. If I want to make it 2 times a times b, what can I multiply that by that will make it 3? Well, how about 3 halves? Yeah. So if b is 3 halves, then b squared here will be 3 halves squared, which is 9/4. I'm going to add 9/4 to the left and 9/4 to the right. Okay, so you may remember that a squared plus 2ab plus b squared actually factors to a plus b squared. So now I'm going to factor each perfect trinomial and I'm going to add together the terms on the right hand side. They need a common denominator. We'll use 4. So -14/4 plus 16/4, which is 4 wholes, plus 9/4. So we have x plus 2 squared plus y plus 3 halves squared equals 16 minus 14 is 2 plus 9 is 11/4. I now have my equation in standard form, and I can call out the radius and the center. So here my center is -2, -3 halves. Remember, we use the opposite sign. And the radius is the square root of 11/4, which is the square root of 11 over 2. Remember that this 11/4 is equal to r squared, not just r.